Okay, so this is the second video for section 12.3, Measures of Dispersion. This problem says the following table shows the revenue for each quarter of mega cash run in billions of dollars. Use this information to answer the following questions. During which year was the range of quarterly revenue the largest? Now I know that we can just look at this and see that, but I'm going to list it out here. So in 2016, my largest value was 7, and that means 7 billion, by the way, so 7.0. My smallest is 4.0, so that is a range of 3.0 billion for 2016. And then in 2017, whoops, my largest value was also 7. My smallest one is 3 billion, right? So 4 billion. And it said during which year was the range largest, so that was 2017. All right. And then we're going to find the standard deviation for all 8 of them. These numbers are kind of nice to work with because they're just pretty small here, so we don't have as much to write out. I do put the the decimal part of it though, and so we'll have to do that. But first, remember, we have to find the mean because we can't find the deviation from the mean unless we know the mean. So my mean is going to be the total of these. So if you total them up, you get 44.5, and we're dividing that by 8, and that gives us 5.5625. And just so when we're calculating all this data, we don't have to put in quite as many digits, we are going to round this to 5.56 billion. Now, you don't have to put the billion part on here. We're going to calculate simply with the numbers in the chart and 5.56 for our number when we subtract. So we're going to take each of the numbers in the chart and list them. And I'm just going down one column and then the other one. So I did the 2016s first, and then I went to the 2017s. Remember, we're going to subtract 5.56. This was our data, all right, our x. And then we're going to have the x minus our mean. That's going to be our next column. And then we're going to square that for the column following that one. Now I'm only going to show the subtraction part here. For the rest, I'm not going to show the subtraction. I'm just going to do the subtraction. So just grab your calculator and subtract each one. Don't forget to go ahead and square it while you have it on the screen of your calculator, because that just means you don't have to key in as many things. I'm going to pause this and finish the chart. So remember, I'm just subtracting and squaring, subtracting and squaring. Okay, I'm back. I'm going to write this last number here. I have this thing that shows up when I pause that causes me not to be able to write right there. Okay, so this is these are all the subtractions down the center column, squared on the other column. Let me double check all my numbers here. Okay, you do have to be really careful. As you can see, we're doing a lot of calculating. So we want to add up this column because we need that for the formula. And that's 14.2188. That's my sum. Notice all these values when we square are going to be positive every single time. So, if you should get a negative number depending on how you enter it on your calculator, then just know it will need to be positive. Just take the negative off, basically. On this center column, if I add them, I get 0.02. Remember, it's normally going to be a 0, but we did round this one, so I just wanted to kind of point that out. Oh, I don't know what happened to that digit. It's supposed to have a 2 right there. Okay, so now we go to our formula, right? Our standard deviation is going to be our sum 14.2188. It's important not to round here, right? Don't round it on any of this. We're dividing by 7 again because we had 8 values in our data. And so my standard deviation is 1.43 billion. So remember, that's how much it varies on either side of our mean. And then I'm going to show you this next slide that shows the normal distribution. So we'll talk about that. If we add or subtract that from our mean, then about 68% of it will fall in this normal distribution. So a lot of people have heard from the normal distribution, sometimes called a bell curve, and then it just shows the numbers that kind of work out approximately. Now this is for large sets of data, but basically what happens if we take our mean and we add 1 standard deviation or subtract 1 standard deviation, that's going to be in this area right here. And that's an approximate value. It doesn't come out exactly 68, but it's approximately. And then if we, it's doing that crazy thing where things are disappearing. Okay, I'm going to pause it just a minute. So on our last set of data, if we had taken our mean, 5.56 billion, and we add and subtract the 1.43, then approximately that many of our numbers would fall in that first area of the 64.2 or 68.2%. And then if we go further out, that's approximately 95. So if we add 2 standard deviations to the mean or subtract 2, then about 95% of the data would fall in those ranges. And so I'm going to show you that on a couple of problems here. Okay, so here's what I did. I took this set of data and I just gave you the mean and the standard deviation. The reason I did that is because calculating that whole thing with so many numbers is tedious. I forgot how many. I think there's about 15 of them. And that's definitely a lot of calculating to get the mean and your standard deviation. But we're going to use that to answer this question. Now I'm going to tell you this. None of these are on my lab because, I mean, there are, but you have to figure the mean and the standard deviation. So I'm taking that part of it out. So on your written homework and on the tests that you'll take, you will have this information given to you in this way. Okay, instead of having to figure it all yourself. What we're going to do is take our mean of 7.489 and we're going to add, or let's subtract first. We're going to subtract 0.0170 and that's going to give us 7.472. And then, you know what, I need to scoot this down. Hold on, so I can work with these numbers in just a minute. Okay, let me lower that. Okay, take the mean, subtract, and then take the mean and add that same thing. And that's going to be our range of where the values might fall for about 68% of the data, because I'm asking you to find that. And so that gives us 7.472 and 7.506. Now we're going to find the numbers that fall in this range here in our data set up here. Oh, we have to know how many numbers there are. Oh, there's 14 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 14. Okay. So it has to be between these numbers, right? And we're just going to underline all the ones that fall in this range. So I'm going to underline them as I go through the list. And you just have to kind of look and see, is this in this range or not? And then we're going to count how many numbers we underlined, double check. So you can see 7.47 is close, but it's not in the range because it doesn't have a 2. That's like looking at it as 470 versus 472, so it's below the range. Of course, 46 is below the range. 51.51 is above the range. So those don't count in our data. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Part B is going to be that 8 out of 14 fall in this range, and that turns out to be about 57%. Right, we're going to round it, or we're going to divide this and then multiply it by 100. And that's where that came from. So 57%, the normal distribution says about 68% is going to fall in that range. But remember, this is not a real big set of data. The bigger the set, the more accurate that gets, usually. Okay, and then let's look at the next one. Okay, on this one I'm asking you to find 95% of the range, and that's going to be minus 2 standard deviations or plus 2 standard deviations. I gave you the mean and the standard deviation on this. So we're going to do the very same thing. For part A, we're going to take 284.4 and subtract 6.30, and we're going to also add 6.30. Okay, so when we subtract, we get, set 271.8, and when we add, we get 297.0. So we need to be between, yeah, let's put two E's in there. We need to be between 271.8 and 297.0. Okay, so we're going to see how many of those fall in that range. Well, this one works out kind of funny because actually all of them do. If you look through, you're going to see none of them are below 271.8. Right? Just look through it. And none of them are above 297. So in this case, remember the percentage is normally 95. We get 100% on ours. So 15 values out of 15 fall within 2 standard deviations. And actually we get 100% on that rather than 95. And that's okay. That's okay. That's just, you looking at normal distribution. If you look back at what it says, given a large enough sample, the distribution of measurements of many objects or processes tend to approximate what is known as the normal distribution, and this graph illustrates that distribution. So that is what you're going to need to know for standard deviation. You can find the range. Can you find the standard deviation? Can you talk about normal distribution given this information, right? Remember, I'm not going to make you take a large set of data like this and go through that whole process of the standard deviation. I will give you smaller numbers on those. All right. Well, that's it for this last lesson of the semester. Bye, everyone.